My name's Scott Rosenberg, Practice Leader for Cloud Technologies and Automation at TerraSky. Today, we're going to talk about Tanzu build service and the path to microservices. Now, today in different organizations, we see that the terminology of microservices and containers are used interchangeably. Usually when an organization is going down the path of adopting a microservice architecture, they also at the same time containerize their applications. Now, building containers at the beginning can be a very exciting and fun task because it's a new technology. But building containers properly is a very complex task. Now, let's take a quick look at how this is usually done. So, the first step is obviously going to be writing our application code. So once we have our application code and our developers have done this, we now go down the path of actually creating a container image that can house this application code for us. So in order to do that, traditionally what we're going to do is build what's called a Docker file. Now, a Docker file is a declarative file that has within it a set of commands in an ordered fashion that say exactly what needs to be done in order to build this container. The first step is going to be what our base image is. So we need to say which operating system, for example, this container is going to start with. Once we have that base image, we then need to go and install our libraries. So we may need a different set of libraries for each of our applications. And not only do we need to say which libraries, we also need to give it the right commands and give it the right orders in order to have it install the libraries in the correct and appropriate fashion. Once we've done that, we then need to go and install our runtime. So this could be different runtimes. This could be Springboot for Java. This could be things like NodeJS. For different languages, we need different runtimes, and so we need to install that here. And once we've installed our runtime, we then need to go and compile our app. Now, once we've compiled our application, usually the compilation uses some additional tools than what we actually need in our container image. And you see, building a container image properly, we have a lot of things we need to take into consideration. On one hand, we need to make sure that it's secure in terms of permissions. By default, a container runs with the super user permissions. It runs as root, and this is very insecure. So maybe we need to deal with that as well. We also need to deal with other security measures. You know, as big as our container image gets, that opens up more vectors for attacks. That opens up more places that can have vulnerabilities within our image that could be exploited. And also, we need to make sure they're small containers, as small as possible, so that that initial download time is as short as can be. So the next step that we need to do is a cleanup. So this could be, for example, if we were using Java and we needed the JDK, the Java Development Kit, in order to build our image, we want to remove that and just have the Java runtime environment in our image when we actually go to run it. Now, once we have this Docker file, our next step is going to be running a command. Usually, this is going to be a command like docker build. And what this is going to do is it's going to take the Docker file that we created, and it's going to build a Docker image for us. Now, once we have that image created, our next step is going to be pushing that into a registry, which is a place in which we can hold our images, and we can pull from there the images at any time. This could be any registry. It could be something public like Docker Hub or ECR or GCR. This could be a on-prem hosted one. This could be whichever different registry we would like, for example, Harbor or Artifactory. This may not seem that complex, but building a Docker file correctly is not an easy task. Every single language has different best practices, has different standards of what the correct way of building an image for that language is going to be. And to have our developers not spend all of their time or the majority of their time on their application code and need to spend this time on how to build a Docker file, how to package that up into a container, is taking away from the time that they could be investing into advancing our business and dealing with moving the business forwards. So VMware have come to us with a solution that helps us make this process a lot easier. And this tool is called Tanzu Build Service. Tanzu Build Service is built off of the Cloud Native Computing Foundation project, Cloud Native Build Packs, which has its roots in the Build Packs project built by Heroku back in 2011 and adopted shortly after by Pivotal in the Cloud Foundry ecosystem. In 2018, Heroku and Pivotal came together and created what we know of today as the Cloud Native Build Packs. Now, Cloud Native Build Packs has a few general goals. First of all, it's a specification. It's a specification that tries to help build a standard way in order to build our applications, to build container images according to industry standards in a reproducible and secure manner. So let's see how it does this. Now, the first step that we have when we build one of these images is going to be the exact same as it was before. We're going to have our application code. So nothing changes here. We write the same code as we would if we were using a Docker file. But this application code now, we're going to pass to build packs and tell it, hi, please build an image for me. When we pass this application code into build packs, the first step that's going to happen is a step called the detection phase. Now, what happens here is a lot of the strengths of build packs. I don't need to tell build packs which language my code is written in, which compiler it should use, which dependencies I need. That's all written if I'm using Python in a requirements.txt or in every language in their different manners. And once I have my application code and I pass that into build packs, what the build packs are going to do is they will detect what languages am I using in my code, which compiler does my code need to use, what other dependencies may it have. This could be dependencies of using something like SNCC for static code analysis even. Now, once we've run this detection, the next phase we have is that build packs is going to analyze our code. And it's going to try and understand exactly what the order of operations that it needs to take are in order to build this image for me, according to, once again, industry standards in an up-to-date and secure fashion. Now, once this analysis has happened, comes the key part, which is actually building that image. And build packs will come and take the base image that we tell it, we'll take our application code, and we'll download according to the best practices built into build packs. It will download the requirements, download the libraries and runtimes, compile our code, and in the end, it will export our container image for us that we can use. Now, as we said, build packs is a specification. And there are many different implementations that use build packs today. The most common one is a CLI tool, a command line tool called pack that is created by the Cloud Native Build Packs community. Now, Pack CLI is a real easy tool to use in order to get started with build packs. But VMware understood that the Pack CLI, as strong as it is and as capable as it is not the full solution that we need when we're talking about an enterprise organization. We need something that can wrap this up and give us even more of an enterprise-like experience. And that is what Tanzu Build Service brings to the picture. Now, as we said, Pack is a CLI tool that could be run from my computer or from a CI/CD system. And what Tanzu Build Service does is that it packages up build packs and actually imports that into Kubernetes using another implementation of build packs called Kpack, an open source project developed originally by Pivotal. Now, Kpack uses the operator framework within Kubernetes to allow us to declaratively create custom resources and then manage their lifecycle within Kubernetes just like we would any other native object like a pod or a deployment. In our case, let's talk about one of the main custom resources, which is an image. An image is going to be the specification given to Tanzu Build Service for how we want it to create for us a container image. Now, because this is constantly running within our environment, one of the things that this allows us to do is to automate the process of updating these images. So let's talk for a second about what updating an image looks like in the traditional world. Now, building the image, we said, is not an easy task, but it's doable. But if I have dozens to hundreds of containers in my environment that I created, what happens when I need to go and update different libraries? Different language runtimes and operating systems have updates on a weekly basis for security patches. To manage this for every single one of my images is very, very difficult. That means I need to go and manually edit my Docker files. I need to then go and rebuild the image from the bottom up. That means, again, creating that base image, downloading and installing the libraries and runtimes, compiling my application again, cleaning up that image again, pushing it back up to the registry. Again, this is a lot of work. Now, once we've done that also, our entire Docker container is a brand new container. Everything is new. And that means we need to do our entire test cycles again on this new artifact. So let's look at how this is actually done in build packs, and specifically in Tanzu build packs. So if we look at actually what came out of this export at the bottom, let's try and understand what this image actually looks like from a build pack exported image. If we look at one of these images, the image is actually built with layers. So we're going to have our base layer. And this is where our base image goes, similar to our Docker file. Now, above that, we have our library layer, where all of our libraries are located. Above that, we're going to have our runtime. And above that, we're going to have our application. Now, building an image into layers like this, in the way that build packs does it, is a very strong part of the product. Because this allows us to use what build packs calls the rebase mechanism. Now, let's say that there is an updated version of NPM. Or there's an updated version of Ubuntu, which we're using as our base image. How do we go and update this? So in build packs on its own outside of Tanzu, what we would have to do is actually take the pack CLI and tell it to rebase our image and point it to a new base image or to a new build pack for an updated version of that specific language. As we can see, this is already so much easier than the traditional approach with Docker files, where we need to go and manually update our Docker files with all of these different dependencies. But the difficulty is still that we don't know necessarily when Ubuntu and NodeJS and even the built-in libraries like OpenSSL or SSH or different libraries like that all of a sudden get a CVE patch and have a new release. So how do we manage this? Now, in Tanzu build service, we have another component. And this component is what we call the TanzuNet dependency updater. Now, what does the TanzuNet dependency updater do? We have the Tanzu network up in the cloud. And VMware have an entire division of people working around the clock, understanding what new libraries, what new CVE patches came out for the different build packs, for the different runtimes and libraries and base OSs, and are pushing to the Tanzu network new build packs with the updated versions, new base images with the updated operating systems. And the Tanzu network deployment dependency updater is in constant contact every few minutes, checking with Tanzu network to see if there are any new updates that it should be applying in the environment. If there are any new updates, what the dependency updater is going to do is it's going to let the Tanzu build service mechanism within your environment know that there is a new update for its different dependencies. Now, this could be saying, hi, there is a new base image of Ubuntu Bionic, or there is a new patch version for Springboot. And when this happens, automatically, all of our images that we have built, whether that's 1, 10, or even hundreds of images that use that specific base image or that specific build pack, will automatically be triggered to be updated with that new patched version. Now, you may come and say here that this seems very scary because, again, we're going to what? Just because it's happening automatically, we're going to rebuild our entire images and have a system automatically go and recompile our code for us? Well, how do we know that that's not going to break our application? And this is where we need to understand a term called ABI, Application Binary Interface. And there is a contract built between different interfaces of languages and runtimes and libraries and operating systems that they all comply to, saying that Node.js, if it's a patch release, will not break its interface with an application that's using it. And Ubuntu will not break its interface with the applications running on top of it when it's a patch release. And because we know this, because we have this contract called ABI, what can be done is that we can actually automatically update our images without worry. Now, how does this get done, though? Because, again, if we go and rebuild our Docker file, we did change things. So, build packs, and this is in any version of build packs. What happens is let's say there's a new version. TanzuNet comes and tells my dependency updater that there is a new patched version of Ubuntu. The Tanzu dependency updater is going to push that new base image into my local registry, which for this case, let's say, is going to be Harbor. And it's going to push it up to my Harbor registry. And it's going to let Tanzu build service know that this is the new image that it should be using. immediately when the rebase happens, what is going to happen is in all of my images, Tanzu build service is going to build a new layer for me. Now, that new layer is going to be a new base layer because this was done with Ubuntu, and that's where the patch happened. But once I've built this new base layer, nothing actually needs to change with these 3 layers, so they aren't even recreated. All that happens is that BuildPacks replaces this layer here with the new layer. Now, this happens at any layer across the board. If I have Tanzu build service constantly monitoring my Git repository and updating my image anytime a new commit happens, then after that first initial image creation, my runtime, libraries, and base image, if I haven't changed any of my dependencies in my code, won't be recreated either. They will just be mounted with a new layer on top of it of app v2. And if an update came from Tanzu network dependency updater saying that there's a new version of my runtime with a patch, all it's going to do is have run v2, and everything else can stay the same. We don't need to rebuild all of our layers. We don't need to push our entire container image again and rebuild it every single time when only a single layer changes. And this is a huge benefit. This can save hundreds and hundreds of hours spent within organizations trying to maintain and update their images. Now, we at TerraSky work with our customers to try and help them migrate to a microservice architecture. One of the main parts in this is trying to understand what the right ecosystem for them is. How do you choose the right ecosystem tooling? How do you make sure that you create a path to success? Now, we at TerraSky can help you figure out how to spend as much of your time as possible on your business goals, on your business needs, on your applications, on adding value to your company, rather than dealing with all of this configuration that needs to be done when we do things in a manual and traditional manner. Now, you can learn more with our introductory workshop, The Path to Microservices. Thank you for joining us today. Have a nice day.